Now we go to section 2. Section 2, answer 2 questions. Section 2 now, answer 2 questions. Show by calculation that the exact roots of the quadratic equation is these. So to find the roots of a quadratic equation, just go straight to the quadratic formula, and it's minus b, which is -2, plus or minus the square root of b squared, which is 2 squared, minus 4 times a is 1, times c is -5. All of this is being divided by 2a. A is 1, so it's divided by 2 times 1. And when you do this division, you're getting x is equal to -2 plus or minus the square root of whatever this works out to be. That looks like 2 squared is 4. 4 minus 2 squared is 4. That is 4 minus 4 times 5 is 20. So it becomes the square root of 24 over 2. All right. Now I want to point out this, that the square root of a number, let's say even 49, right? The square root of 49 can be written as the square root of 7 times 7. And so the square root of 49 is the square root of 7 times the square root of 7. You might wonder, why am I telling you this? Why am I telling you this? I'm telling you this because, and if you don't believe it, try it in a calculator. All right, why am I telling you this? I'm telling you this because we can break out this square root 24 as, the square root of 24 can be written as, this is going to be -2 plus or minus, this can be written as the square root of 4 times the square root of 6. That is 24. The square root of 4 times the square root of 6. And it's being divided by 2. Now, -2 over 2 is -1, plus or minus. Now the square root of 4 is 2, and 2 divided by 2 is 1. And so we're left back with just the square root of 6. And so x is equal to -1 plus or minus √6. Very easy question. No issues. So the trick with this question is just to know that you can separate the square root of a number as the product of the square root of 2 numbers. So just to leave the rule, the square root of a number AB can be broken up as the square root of A times the square root of B. All right, that's a new rule. It says, hence or otherwise, solve the simultaneous equation 2x plus y, 2x equal y and xy equal 5. Anytime you're given a line and a curve, you substitute the line into the curve. So this right here is the line. It says 2x, call this equation 1, 2 plus x equal y. And so when we substitute that for y, we have x times y is 2 plus x. And this is equal to 5. So multiply them across, we get 2 times x is 2x, plus x times x is x squared, x times x is x squared, and that equals 5. So we can bring over the 5 over here to get x squared plus 2x, x squared plus 2x minus 5, and that is equal to 0. Now, we just were solving this and it said hence. We just solved this quadratic equation. We just solved it and we found that x is minus 1 plus or minus the root of 6. So we don't need to solve it again. We just need to write that down, that x is equal to negative 1 minus root 6. That's one answer. And another answer is x equal negative 1 plus root 6. Now, if you're not comfortable working with square root, you can put it as a decimal if you want. Put it as a decimal if it's confusing. Put it as a decimal. So minus 1 minus the square root of 6 minus 1 minus the square root of 6 is negative 3.44, negative 3.45, and then this negative 1 plus root 6, negative 1 plus root 6 is 1.45. So this right here is 1.45. Now you can find y. Now when x is negative 3.45, y is going to be equal to, right here, you put x as negative 3.45. 2 plus negative 3.45 is negative 1.45. So that's one answer for y. And the next answer for y is when x is 1.45, y is 3.45. This will give you y. So those are the two solutions. All right. So if you want, generally sometimes you see them, they do this. They can put the solution as a set of coordinates. They can write it as solution is negative 3.45 comma negative 1.45 or 1.45 comma 3.45. So those are the solutions. All right. Now this question now says the incomplete table below shows the values of x and y for the function y equal 2 to the x. Complete the table. So to complete this table, all I need to do is put in a calculator when x is negative 1. When x is negative 1, y is 2 raised to the negative 1, and 2 to the negative 1 is a half. So that's 0.5. So you're getting 0.5. And then when x is 1, y is going to be 2. When x is 1, y is 2. No issues there. When x is 2, y is 4, because 2 to the second power is 4. So that's 4. And then when x is 4, 2 to the 4th power is 16. 2 to the 4th power is 16. So that is y. So that's the table completed. Then it says on the grid provided on the next page, draw the graph using a scale of 2 centimeters to represent 1 unit on the x and 1 centimeter to represent 1 unit on the y. They already give us our x and y axis, which is good. So all we need to do is use 2 centimeters to represent 1 unit on the x. So 2 centimeters represents 1 unit on the x. So this is 1, this is 2, this is 3, this is 4. And I think we're plotting between negative 1 and 4, negative 1 and 4. -1, and 4. So this is it now, -1. Then we're using 1 going up on the y. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. We'll continue going up. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. This up here is 20, which didn't go so far anyways. All right. So now let's go ahead and plot the points. We know that the points together were negative. When x is -1, y was a half. When x was -1, y was a half. Just to check again, x is -1, y is a half. So where's a half? If this is 1 and a half, it's going to be somewhere here. When x is 0, y was 1. I think I'm going to use black for the points. When x was 0, y was 1. When x is 1, y was 2. When x was 2, y was 4. When x was 3, y was 2 to the third power was 8. When x was 4, 2 to the fourth power was 16. Y was 16. So what we're getting is a smooth curve. My curve not so smooth, it's a little bit tacky. That's the curve we have between -1 and 4. All right, mine not so smooth. Make sure it pass through all the points. I didn't do that. Let me try to fix it. And that's that. All right. And it don't want nothing else. It just want to draw the graph. What else it asks for? Oh, drawing the appropriate lines on the graph. Determine the value of x when 2 to the x equal 11. So finally, 2 to the x equal 11. So we're going to draw the line y equal 11. So the line y equal 11 is right here. And according to my not accurate graph, the solution I'm getting is right here. So when x is 3.6, 3.6, so it's telling me when x is 3.6, this is an x value of 3.6. Let me not write 3.6 way out here, because this is a line y equal 11. Let me label it as y equal 11. So now, when x equals 3.6, we get that y is 11. All right, so the solution is 3.6. We're going around here. Determine the value of x from the graph. From the graph, I'm getting x equal 3.6. Now, of course, if you're to put in 2 raised to the 3.6, you're going to get 12, but that's just from my graph. So that's what I was getting from my graph, which wasn't so accurate. All right, so can't kill me for that. My graph wasn't accurate. The more accurate it is, maybe you got 3.5. And if you try 2 to the 3.5, you get 11 point something. So the more accurate your graph, the better result will be. Well, let me see, the 3.7, 3.5, 3.75 is actually 3.55. Actually, my graph is giving me 3.55. All right, it's not so accurate, but you have to see it. Nice.